Hello everyone, my name is Chandra Prakash and my registration number is 222704 and I am from MTech Data Science. My topic for presentation is face detection using Haar Cascade. So these are the main steps of face detection using Haar Cascade. As you can see, we take the input image, then we do Haar feature selection on the input image, we calculate integral image, we do Adaboost training to reduce the number of facial features, to reduce our computation, and finally we further use cascading classifier to ultimately do the face detection. So detailed workflow will be seen in the subsequent slide. First of all, what are Haar features? So Haar features are nothing but group of pixels divided into two parts, black and white. So some regions are white and some regions are black, and these Haar features are helpful in doing the face detection. We will see how these features are helpful in doing face detection in subsequent slides, but for now we just have to remember that Haar features are nothing but group of pixels divided into two regions, white and black. That's it. And we can have different Haar features, like these represent edge features, these represent line features, and these are four rectangular features. Now one more thing as far as Haar features are concerned is this delta value. So delta value is nothing but the white region minus black region. So for this particular example, this white region 4 minus 3 black region, that will 1. Now talking about delta value for the group of pixels, like this is the ideal case when you have perfect white and perfect black. So simply you have to take the mean of this white portion 255 and mean of this black portion and take the difference. So this is 255 and this is ideal scenario, but in reality you will not have a perfect 255 and perfect 0 value. So we have to take the mean of all these whitish pixel values and mean of these blackish pixel values and take the difference, and this will, if delta value is high, that is if this delta value is near to 255, then this will represent a feature which is Haar like feature. So we have to keep in mind our delta should be as high as possible for it to be considered a Haar feature. So why we want high delta value? So you can consider this example. So this eye portion will have little bit black and this portion below the eye will have white. So if you take the difference, you will have high delta value. White minus black will have high delta value. So in this way, this high delta value is able to give us Haar feature for doing the face detection. But if you consider this area here, this nose area will have white and this is also white, so we don't have high delta value, so this won't be that useful for doing the face detection. So as we saw in the previous slides, this particular area will be little bit darker as compared to this particular area, so white minus black. So this particular Haar feature will give you like feature related to eyes. And one more example is here. This nose portion will be white compared to the eyes portion, so this particular Haar feature is giving you the nose features of nose. Now coming to integral image. So the Haar filters, the Haar kernels, they can be of different sizes. You can see here, this is small, this is big, and this is much bigger. So accordingly you will be able to detect number of features, high number of features for different Haar filter sizes. So your computation will obviously increase. You'll have to do a lot of computations for those for detecting those Haar features. So how to tackle this problem? So the way we tackle this problem is by using integral image. So in further slide we'll talk more about integral image. So how do we calculate the integral image from our this original image? It's nothing but simply the sum of all pixel values towards upside of this pixel and towards left. So if you want to calculate integral value for this particular cell, it's simply summation of all these yellow shaded, means all the upper and towards left. So it's simply 0.1 plus all. If you take this summation, you will get 1.2. So in this way we calculate integral image. In this way we are able to calculate the integral pixel value of all the cells. So so if we consider like a small a region, or like if we have this kind of image and we want to do the Haar feature calculation for this particular region, so you will have to do number of times, like taking their sum, mean. So a lot of computations is involved. So how do we reduce this? So this we are able to reduce our calculation by using the integral image. So if you want to calculate delta for this particular window, yellow shaded region, we want to calculate delta, it will be nothing but we have to only consider the corner points. We need not consider all the pixels which are there inside the region. We just have to consider the pixel values which are there, which are at their corners. This. So for this particular reason, the delta value will be simply 3.7 minus 0.5. Then we have to add this pixel and finally subtract. So in this way we need not do like individual adding of all these pixels. We are simply taking into consider 4 pixel values, and that is giving us the delta. So in this way we are able to drastically reduce the calculations. Now how many features we can detect using these Haar filters? So we are able to detect astonishingly 180,000 plus features. Why? Because these filters, they can be of different sizes, they can be of different orientation, they can be on different positions. So all these combinations, if you take into consideration, you will be able to detect around 180,000 plus features. But like doing calculations for all these huge number of features, it's very computationally expensive. So we'll see in further slides how we are able to tackle down this problem. So in order to reduce the number of important facial features, we are making use of Adaboost training. So in Adaboost training, what we're doing, simply we are like we are training our classifier to differentiate between the important facial features and the irrelevant features, the features which do not represent the faces. So this algorithm will be able to once we give all these like images of faces and non-faces, it will able to detect only those like few 6,000 features which are important for doing the face detection out of these many facial. So in this way we are able to reduce drastically from these high number of features to around 6,000 features. So in a way we are able to reduce lot of calculations and computations. And after Adaboost training, we are making use of Cascading classifier to further make our process faster of doing the face detection. So in this way we have multiple classifiers. These classifiers are able to detect a certain number of subset of features. So for example, out of 6,000 features, this classifier is detecting like few hundred features. So one by one our window will slide through the entire image, and for a particular window, if like for this classifier we don't have those facial features, then it will directly go out of this, and it will say that that particular thing is not a face, so we did not check for that particular window all those features, so it's making our process faster. And suppose that particular window contains a face, then it will check for this classifier. If it says that it may be a face, it will go to another set of features, this classifier 2. If it also says that it may be a face, then in this way we are able to go through all the features, and finally it is able to say that this represents a face. But at any stage, if we are sure that those features is not representing a face, will come out, and in this way we are saving a lot of calculations. So the main use of cascading is to make the process much faster, further faster. Now I'll talk in brief about how classifier is working. So the main aim of classifier is to find out whether a particular window contains a face or not. So in this particular window we don't have face, but in this particular window we have face. So the job of classifier is to find whether that particular window is face or not. So how that classifier is working, we'll see here. So this is our input image. We apply all these Haar filters, and we calculate the Haar features. These represent the Haar features. And so suppose this is our test image. We want, for this particular image, we want to do the face detection, whether this particular portion represents a face or not. So we'll do the Haar features and do the plotting. All these represents the, like, this algorithm is supervised learning. So all these we have already already our classifier knows that all these are facial features and these are non-facial features. So if any new image comes, it will plot those features, Haar features, and check the nearest neighbor. Okay, so if suppose this particular thing is nearer to this, so hence this particular portion represents a face. But suppose that this particular point is near to non-facial features, then the output will be non-facial. So we just have to find the nearest training sample which represents face or not. Accordingly we will decide whether that particular portion contains a face or not. Now coming to few applications of face detection. So I guess you are very well aware of face detection in our smartphone camera app. With the help of face detection algorithm, it is able to identify which region of our image contains a face or not, and if and it will draw a rectangle around that our face, and in this way it will apply autofocus, color balance, all those things. According it will apply to a face, so to give high quality to your images. Another application of face detection in doing surveillance and CCTV surveillance of public places. We are very well aware of this. Now coming to the code, how do we implement this Haar Cascade classifier for doing the face detection in OpenCV? So if we go to the OpenCV manual, we have got this XML file. From there I have downloaded this XML file. It contains all those Haar features which represents face. So we are giving this all these Haar features which represents face to our Cascade classifier. So accordingly, given this input image, we are giving this input image here, we are converting that input image to grayscale to reduce the computations, and finally we are giving that classifier, we are applying classifier to our input image, this gray image, and wherever we are finding the faces, where it will draw the rectangle, so it will give you the coordinates of that rectangle. So once we have got this coordinates x, y, w, h, x, y represent the top left corner point and width and height of that rectangle. So we'll draw using these coordinates, we are able to draw a rectangle around our face. And if we are not detecting any facial features, then we'll simply display the output, no faces found. So here we see the output of that code. So this was our input image, and we have applied Haar Cascade classifier. So and we have drawn the rectangle around the detected coordinates, and this is very well giving us the good output. This is our face detection. Now coming to the references, so this particular is a IEEE published paper. So this paper talks in detail about Adaboost training, cascading classifier. So this is a very good paper. Then OpenCV manual. So all those OpenCV functions which like Haar, Cascade, classifier, those things are covered in detail in this particular link. And this is like lecture by Professor Sri Nair. He talks more about classifier in his lecture. So this was all about my presentation on the topic face detection using Haar, Cascade, classifier. Thank you for giving your time, and once again thank you very much.